My name's Simon. I was asked earlier by Fran to give a talk about the physics of the three towers. Now, normally I'd use this as a way of trying to convince people that 9/11 was a false flag, as probably everyone here knows already. So I'm kind of conscious I'm kind of preaching a little bit to the converted here. But certainly this aspect of it was the thing which totally convinced me. And it's the thing which I've had most success using, trying to convince others. So what I'm going to do is a little talk about the physics of the three towers. And the important thing for me about this particular aspect is that all other arguments and conversations about 9/11 revolve around people's motives and what was on people's mind and what went before, what were this kind of circumstances surrounding it. Whereas this is the only proof which relies entirely on the laws of physics and eyewitness testimony. And the only eyewitness testimony that's involved is your own. So you don't have to rely on anyone else other than your own observation, physics, and a little bit of common sense. And when I say physics, I don't mean complicated degree level physics. I don't mean anything more complicated than the average 14-year-old schoolboy or girl would know. So it's nothing complicated. So hopefully this will be useful to you. So what I'm going to do, I'm just going to start with, just to remind ourselves, I'm sure we all know this, but I'm going to remind everyone anyway of the basic facts of the three towers. So we've got three buildings. Right, so we've got three buildings, and we all know that a plane hit this one, a plane hit this one, and no plane hit this one. And we know that sometime later, in all three cases, the buildings collapsed at an enormous speed. So what I'm going to try and demonstrate is that this couldn't be as a result of those aeroplanes hitting them. Okay. So what I'm going to ask you all to do is come with me with a little thought experiment. So what I'd like you to do is pick any of the buildings. Easiest if you pick building 7, because it wasn't hit by a plane, but the argument applies to the other two as well. And imagine the whole mass of the building being divided into ping-pong balls that occupy the volume of the building. But ping-pong balls with some weight, imagine them with some water in or something. And the next thing I'd like you to do is imagine just one of those ping-pong balls. It helps a little bit if you imagine one near the top, but it doesn't make any difference. If you prefer to imagine a different one, that's fine. So, there's a ping pong ball. So, now let's try and work out what could happen to this ping pong ball during those few seconds when those buildings came down. So, I can think of a couple of models of what could have happened. Okay, there's one, and there's two. So the first one is that this ping pong ball could just fall to the ground without striking any other objects. This is the simpler of the two models. So it falls down, and sometimes later it hits the ground. Okay, so that's the first model. And in the second model, what we're going to imagine is it hitting debris. Imagine these to be bits of concrete, steel girders, whatever that comprises the mass of the building. So it'll fall, strike another one, come off, and then fall, strike another one and come off. And how many times it does that, anyone's guess. Okay. So those are so obviously this model here is commensurate with some kind of free fall type activity, and we'll come back to what could cause that in a minute. I guess you can probably all guess, but we'll leave that for a minute. And this one is commensurate with some kind of pancake collapse of the building, so structural collapse and things hitting things, and the building gradually falling down by hitting itself and collapsing gradually. Okay, so let's see if we can work out which one of these closely models the actual observed facts. Okay, so I'm going to use here an equation from Isaac Newton. So F equals ma, which you've probably all heard of. So m is the mass of the ping pong ball, F is the force acting on the ping pong ball, and A is the acceleration that we're going to observe. Okay? And in this particular case, there's only one force acting on the ping pong ball, and that's gravity. Okay? And we know that when this equation applies to gravity, A is 9.81 meters per second per second. Okay, and that's the acceleration due to gravity. That's the acceleration that everything falls at when you just let it drop. In this case, the forces on the object are not just gravity, because another one of Newton's laws says that whenever two objects strike each other, the forces exerted on each object are equal and opposite. So each time this thing that's the ping pong ball that's been hit has a force on it accelerating it downwards, an equal force is acting up on the thing that does the striking. So if you imagine I'm going to put the microphone down for this minute. If you imagine a floor falling in fall and then hit a stationary floor, when it hits, this one slows down and this one speeds up. And the result is that the two floors continue downwards, but at half the speed. Okay. So at each impact, there's another force. So what we'd observe in this particular case is acceleration of much less than this. Now, how much less? We don't really know, but it would be a lot less, especially if there are a lot of objects being struck on the way down. So we're looking at, say, something like between 1 and 2 meters per second squared. Okay. So now we've got a way of working out which of these two things is true, because all we need to do is work out the acceleration in both of these cases. If it comes out near 9.8, it means this model is true. If it comes out near 1 or 2, it means this model is true. Okay? So the next thing we do is we can't work out the acceleration by observation directly. It's very difficult for the human eye to measure acceleration. But what we can do is measure some other things. So we can use another equation, which is S equals half AT squared. This is a maths equation taught to most people in school when they're about age of 14. And S is the distance travelled. A is the acceleration, the same acceleration as here. T is the time taken. And that gives you the relationship between those three things. So what I'm going to do, I'm just going to rearrange the equation now. So I'm going to multiply both sides by 2. And I'm going to divide by t squared. And that will give me A. Now of course, we can find A. And we just need to know S, the distance, which is the height of the building, and T, which is the time taken for the building to fall. And those two facts are both available to anyone on Wikipedia or on many clips of video. You can time it for yourself. And what you get for the buildings is, if my memory serves me correctly, something like 9.8 seconds, 10.2 seconds, and I think it's 6.4 seconds for the smaller building, smallest of the three. Anyway, without going through working out all the maths, what this does, you plug these figures in for each of the three buildings, and you get roughly about 9.5. So what that tells us is, just using the laws of physics, which always apply, are incontrovertible, it was definitely free fall that the building was going through. And what that means is, for every particle of mass of the building that fell, it didn't hit any other object on its way down. So all the mass of the building must have been removed by the time that the building fell through that point in space. Now, the only way I can think of to remove mass, I mean, given that it's not a science fiction class, or, you know, there's no aliens, we haven't got any death rays or access to any fancy things, is basically for it to be blown up with explosives. So that's nearly the end. I want to tell you just one more funny thing. And when I ran through this speech the other day with a friend of mine, he said he actually came up with another way by which this model could be observed. And he said that it could be some force or mechanism that's hitherto not been discovered by science. So I kind of thought about it for a bit, and then I thought, well, let's apply Occam's razor. Do we think that this is some weird magic going on, or do we think that someone blew it up with a bunch of dynamite?
The aliens are with us.
And I'm going for the dynamite. So anyway, that's the end of what I was going to say. So I'll try and answer any questions if anyone's got any. Thank you.
Any questions, anyone?
I've got one.
Have you?
How do you deal with Julie Woods?
If I knew who Julie Wood was, I'd be alright, I'm afraid.
Okay. She is a professor of physics who maintains that the buildings were brought down by rays.
Laser beams or something like that?
Yeah. A little bit like my friend said when I put this theory to him, really. Yeah. I mean, I'd go for Occam's razor on this one and say that the most likely explanation is the simpler of the two.
But the trouble is that the Occam's razor argument is the one which is used to say, well, if the government says it fell down because of plane impact, then that's obviously the simplest solution. Occam's razor.
Well, I mean, the thing about Occam's razor is you can use it to choose between two solutions, but the two solutions or models that you're choosing between have to both explain the facts, and the government's one unfortunately doesn't. So that's not a contender.
Yeah, I mean, I think the physics is the most important thing about this, and specifically Building 7. And I think instead of saying to somebody your government is corrupt, you just say to them, look, this building fell at 5:30 that day at near going through a period of free fall acceleration, which is impossible without the floors being removed below it by something likely to be explosives. Now, you know, you're not saying the government's corrupt, you're just saying that happened, and because they don't know about it, they should be looking at it.
Yeah, exactly.
What the architects and engineers say, they don't go into why or who, they just
exactly.
the physics, isn't it?
Yeah. Just stick to the facts. Stick to the facts.
Yeah, hi. I'm a little curious. It's very interesting what you've just demonstrated there. But my question is, how do you explain the buildings crumbling into dust? That can't be the result of just explosives, could it?
Well, yeah, I mean, that's the thing. If you look into the actual science of what they did, it was more than just simple explosives. These were kind of army compounds going on here. So the evidence I've read is that there was thermate involved, which is a highly... it burns with a very high temperature and can melt steel. And these thermite charges were put in place to melt the girders. And then I think the rest, what's left, was blown up with high-intensity explosives. And the reason why you can see that is because in all the film clips of it, the collapse of the building is followed by these what are called pyroclastic clouds, which are those vast clouds of debris and smoke and rubble, which are like billowing down the streets of Manhattan. And you have to ask yourself, when have we ever seen stuff like that before? The only time you ever really get that is in a volcano, and these come out volcanoes, and obviously they're very harmful.
And the liquid too, the liquid coming out the side.
The liquid, yeah. So the liquid steel, which you can see falling down, as you quite rightly point out, and which remained hot at thousands of degrees C for a long time after.
It was weeks.
That was. Yeah, it
was a hot steel in the ground for several weeks after.
Yeah, I think it was weeks, and they did that from thermal imaging from the sky,
Yeah.
and that was of course caused by the thermate reaction. Now, I know a little bit about this because when I was younger, I used to work in a chemicals factory, and one of the reactions we used to do was a thermite reaction, which is very similar to thermate, and without going through the details of it, it's a very powerful explosion, and it was a very high-tech company. We did the reaction in a metal dustbin, which they provided at great expense. And my job as being a student was to, when the thermite was let off, was to stop people coming through the doors into the area in case they got killed. Anyway, one day I was there, and what happened was they let it off, and they put a very heavy breeze block on the roof, the lid of the dustbin, to stop it blowing off. And the power of the thermite was so intense that the lid and the breeze block rocketed up went straight through the roof of the building we were doing in, and then landed down a few metres from me. So that's the kind of power of what we're talking about. That, you know.
Anyone else?
Yeah, I'm interested in several things. First of all, is if we accept that a building falling into its own footprint is almost always the result of a demolition. I mean, we've seen this enough when 60s tower blocks have been brought down.
I think we can lose the word almost.
Well, okay, yes. How would we expect a building to fall if that weren't the case? So they were enormously tall buildings. If they came down in the same way that perhaps one day the Leaning Tower of Pisa will, they would have devastated huge complete city blocks. That's one thing I'm interested in. So if it wasn't demolition, how might we have expected them to come down? The other thing is, I don't know whether other people saw this. It was about a week ago. There was a programme on terrestrial television. I can't remember whether it was
Channel 4.
Channel 4 about the Zeppelins. The Zeppelins in the First World War and the incendiary bombs that they dropped on London to sow terror amongst the population. I mean, you have to remember that, I mean, nothing like this had ever happened before. This was 1915 or something like that, and the population was quite rightly terrorised, which was the whole purpose of the operation. But they used thermite in their incendiary bombs, and it was interesting. The guy was saying that they had thermite, and then they also had a sort of liquid hydrocarbon, petrol or whatever it was, which will only burn at something like 500 degrees Fahrenheit. And so, the aviation fuel that the planes contained, when they exploded and when they burnt in the floors that they impacted upon, I'm talking about the Twin Towers now, obviously, would have burnt at perhaps 400, 500 or 600 degrees Fahrenheit. The thermite burns at over 2,000 degrees Fahrenheit, which is why the Germans used them in their incendiary bombs. And I thought it was, a light went off in my head when I was watching that. I thought, oh yes, and they're obviously not going to, make the link with the Twin Towers and the fact that thermite had been found in the debris. I mean, that's the other thing, it was found in the debris.
You have to remember, though, this is special aviation fuel, because at the Pentagon it managed to completely vaporise the entire case of the jetliner that allegedly hit it. That's what the government said. They said the fire was so hot that it vaporised the metal. Now, to vaporise that metal that aeroplanes are made of, you actually need a temperature that's hotter than the surface of the sun. So I don't think a little bit of burning paraffin is going to do that.
No, quite.
So anyway, going back to the first point you made, which I think was quite interesting actually, is what would we expect to happen if it weren't controlled demolition? And the problem really with this is that there aren't really that many examples of it having happened. I mean, aeroplanes have hit buildings and there's been fires in buildings and buildings haven't collapsed. But one way you would get is, I suppose, if it, like the Leaning Tower of Pisa is a good example, I guess one day it might lean and just fall flat, like a tree would. And that would, as you say, lie along the blocks of the city. The other way, which has been observed, and this happens a little bit in earthquakes, is a thing called pancake collapse, where the building is shaken a lot, and this kind of loosens the floors. And what happens is they just pop down one on top of the other, and the reason it's called a pancake collapse is at the end of the day it looks like a bunch of pancakes at the bottom, all sitting on top of each other. And of course there's many clips of film and photographs from 9/11, and there's no evidence of any pancakes whatsoever.
Are there any clips of a real pancake? Because that's the official explanation. It was a pancake collapse.
Yeah.
So there are any clips of pancake collapses, real pancake?
Well, I've seen some stills of the aftermath of them, but again, it's very rare because the fact of the matter is that buildings like that don't really come down at all. And they always say that if World Trade Center 7 was caused to come down by a fire, it would only be the third time in human history that such a thing has happened. And the other two happened on the same day, of course.
Well, I thank you very much for this contribution.